I want to do a quick tour through some of the main syntactic aspects of working with React, some of the things that are going to come up again and again. And the first one is this either super liberating, cool syntax, depending on if that's how you see it, or this abomination that shouldn't be part of the web. And let's talk about JSX. So this is JavaScript XML or JSX. And the first thing I'm going to say about it is that it is not technically required for working with React. However, JSX tends to be the main way that people working with React and also a lot of other UI frameworks they've coalesced around this syntax. So let's just talk a little bit about it, and I'll switch my view here. So I want to talk about this line of code. So when you see that, I really wish that I could just chat with you about this right now. Like, how does that make you feel? Are you starting to itch? Does something feel wrong? Like this, to me, if you come at this normally, this is absolutely bizarre syntax, because on the left-hand side here, I very clearly am in JavaScript. But over on the right, it really looks like I'm inside of HTML. So which is it? Is it HTML or is it JavaScript? The answer is that this is 100% pure JavaScript. It is not HTML. And actually, we could say that it's not actually JavaScript either. So one of the things you will see people do when they name their file, they'll have a file.js versus file.jsx. So you'll see both extensions that will be used when people are talking about this in terms of how they refer to it. And some purists are going to tell you that a file that contains JSX should not be called .js because it's not JavaScript. It's this extension to JavaScript. So the first thing I want to talk about is what this actually is, because I want you to, for the moment, just take on faith that this is 100% pure JavaScript. So what are we saying here? JSX allows us to write an XML style, or what looks like an HTML style, but let's be more specific. Let's call it XML. An XML style declarative syntax for creating what are known as React elements. So the reason that this code works, this code actually doesn't work. Like if I try and write this in a browser, like let's just run it right now. So if I were to, or if I'll do it in Node, if I'm in Node and I say const element is equal to h1 hello world h1, you're gonna get a syntax error because this is actually not valid JavaScript. In order for us to be able to do this, it's going to be necessary for us to convert this syntax into a version that actually can be run. So let me show you what this code needs to become in order to be usable. The second line of code there is really what I need to produce. So hopefully this looks a little more familiar. I have an object called React. React has a method called createElement, and createElement takes, an element type, and it also takes inner HTML that needs to be put into this. This second way of doing it, this is the JavaScript, and this here is the JSX. So what we need to do is we need to be able to write code in the first style and convert it to code in the second style, which a browser could run. So to do that, we're going to use Transpiler. And I've talked about this Transpiler a number of times. I'll just mention it here. When you're doing front-end coding, even back-end coding these days, it's very, very common for people to want to use modern syntax in JavaScript, next generation JavaScript, in scenarios where the browser doesn't support that particular version of JavaScript. So what we need is we need a tool that can take JavaScript in one style or one syntax, and it can convert it into an older version of JavaScript or into a more compatible version. So if you take a look at, this is the Babel REPL, and what it lets me do is on the left over here, I can write JSX. And over here on the right, you can see that it is converting it for me into pure JavaScript that I could run inside of a browser. So you can see that my JSX, my XML style syntax here has been replaced with just regular objects and method calls. So whenever we're talking about code that looks like this, or when I'm talking about this code over here, and you see code that looks like this, I want you to imagine that what is actually going to happen when it runs in your browser is that you're going to actually be, the code that you're going to be running is going to look like the code on line 8. And I wanted to at least bring up Babel and make you aware of it, because in a lot of your front-end coding work that you're going to do with Angular or with React or Vue or all these different things, in various places you're going to read about Babel, and you're going to read about Babel plugins. And so Babel is this tool for transforming syntax, transpiling, not compiling, but transpiling from one programming language to another programming language, rewriting it for you automatically so you can do it. Okay, so I just wanted to bring it up so you're aware of it. Okay, so I'm gonna stick with JSX. Now, the reason we do this is that it's a lot more convenient to write this. So like if I have, deeply nested, so if I were to say, for example, I have a div and this is in a div. And let's say that, I also have, where are we here? Let's say I also have an anchor, href equals https web422.ca. So this can get really complex really quickly. If I was going to write this as a series of function calls, you can do it, but it very quickly spirals out of control as this gets longer and longer and longer, and it's really convenient to be able to write it in JSX. So I want you to try playing with JSX. I want you to use JSX. It takes some getting used to. It's not going to feel obvious at first for a number of reasons, and there's some things you got to get used to, which I'll take you through right now to try and show you what's going on. Okay, so let's talk a little bit about how this JSX gets used with React. So I have an example here that React has of sort of like the smallest version of a React application or React that you could use. So we have a web page, and the web page is doing something similar to what we've seen in previous weeks, which is it's pulling in scripts. So in this case, it pulls in 2 scripts. It pulls in React, the development version of React, and it pulls in React DOM. So React DOM is what's going to take care of rendering things to the DOM as opposed to other graphic backends like we talked about with React Native. And React is going to do all of the management and scheduling of our component functions and so on. And you can see here we have an example of what we're talking about with Babel. So up at the top, they grab the react.createElement function and they cache it on this variable e. And down here at the bottom, you can see that they use e in order to generate the, their code. So I wanted to show you this because it's possible to write React this way, but you won't see very many people doing it. You'll see most people will we'll do it with JSX. This example is showing people, you know, what it's like if you're not using JSX. But I want to talk about how we're going to do this with JSX. Okay, so as I said in a previous video, we're usually taught that you need to separate out your concerns when it comes to creating your content, your markup in HTML, your logic, your program, it goes in JavaScript, and your style goes in CSS. But with JSX, we're going to be able to blur those, and we're going to be able to do things all in one space, and we'll look at lots of examples of this. But what's nice about JSX is that everything you know about working with JavaScript you can do here. So for example, if I have a name is equal to Dave, and if I want to say hello Dave, it's possible for me to work with all the variables that are in this scope inside my JSX. So in here, what I can do when I want to reference a variable is I can say hello and the user's name, you know, whatever. This username, my editor is giving me strike through here, which is unrelated to this. Ignore that for now. And what's nice about this is that I can have a mix of HTML-like syntax, and also I can pepper in this JavaScript. So if you're coming from templating, where you've worked with templating engines like in Node, this is going to feel familiar. There's lots of different languages where you'll have templating. Sometimes, you know, the templating languages will do two double parenthesis, or they'll do, you know, something like this, and specify that you're interpolating things inside of the code that you're doing. In JSX, we do it with the single braces like this. So what goes in here is any expression. Any expression, so like if this is an expression in the sense that I want to evaluate this string. I want to evaluate whatever is in here. But this can also be anything you want. So this could be 1 + 1, for example. Anything you can do in JavaScript, anything you can calculate in JavaScript, anything you can express, anything that comes down here will work. So for example, if I said name.to uppercase, that would work, right? I can put any valid expression in here that I want. So, you know, like for example, we could write a function const uppercase equals, you take a name and you return name.to uppercase like this. So I could say something like uppercase Dave. That would work. So I can mix and match any function invocation. I could concatenate something. I could say, you know, user plus this, something like that. So anything you can do in JavaScript, you can do here. And if you want anything, you know, value equals, you can take this and instead of doing it inside of the expression, you could put it in a variable, and I can stick value in here. That'll work too. So it's very, very, it's handy because you're right inside a JavaScript environment. Everything you already know how to do with JavaScript is suddenly available to you right inside the way that you work with what's being built here. And you can, you know, if I wanted to, I can use JSX anywhere that I would use other things. So like, for example, I might say, if, you know, if x is equal to 1, then I want to return, you know, a paragraph and say hello, like so. Else I might want to return a paragraph that's goodbye, something like this. So the idea being that anywhere that I would use an expression, like anywhere that I would return a string or I would return an object or something like that, I can return a JSX expression and it will work here just fine. So I can mix and match these in really interesting ways. Now, a lot of times what's going to happen when you're writing this code is you're going to have some, const element is equal to, and you want to, have a div, and the div has a h1, and it goes on and on and on. And it's not going to be great to do this on a single line. So what you can do is you can wrap this in parentheses like this, and you can do your indenting the way that you normally would. So you can say, I want to set this equal to an expression like so. So if you ever want to have your JSX go on over multiple lines, all you do is you wrap it in parentheses like this. Now, another thing that I want you to notice about the way that we write JSX, so JSX, a JSX expression needs to return a React element. It needs to return, let's just put it another way, one React element. So for example, I can't do this. I can't say list is equal to li1, li2, li3. That won't work. And you can see that I actually have an error that's being produced inside my editor that says JSX expressions must have one parent element. So the problem that I have here is I can't return three things like this. What I have to do instead is I have to wrap them in something. So maybe it's a UL, and I bump all these in, and I close my UL tag like this. So that is perfectly legitimate. So you can build deep, deep, deep trees of elements, and that's perfectly fine. The only thing you have to make sure is that you're always returning a single root. And if you think about think about how an HTML page works. HTML is, just this root element. It's a single element. The whole thing is inside there. And if you go deep inside this, what do you have? Well, eventually you have a body. Everything's contained in the body. And then maybe you have a main element, and everything is contained in the main element. So you have this structure where you always have, at the very, very top of a tree, you have a single parent. And then you can have multiple children below that. There can be lots and lots of things in here, like you can have an H1, and you can have an H2, and you can have lots of paragraphs, etc., all the way down. But I'm going to have a single parent, a single main element, which is the root of all of that. Okay, so let's say something about these React elements. So if a JSX expression needs to return a React element, what is a React element? So these React elements are what React is going to use in its virtual DOM. So where we would produce a real element, like think about how you create a real element in the DOM. I would say const element equals document dot create element paragraph. And what we're doing with React is we're saying const React element is equal to React dot create element p, like that. Or if we do it in JSX, const React element is equal to p, like that. So here we have let's just rename this. I have a DOM element. So this is like native DOM, and this is React DOM. And in the second case, I have JSX to produce it. So when I'm talking about these React elements, what's going to happen with the React element is it's going to be used to create this in-memory virtual representation of an actual DOM element. So I'm still going to need a paragraph element that's going to get put into my page, but React is going to take care of doing that for me. I'm going to model what it should look like. I'm going to model the fact that I want to have a paragraph element. And then React is going to take care of putting that into the virtual DOM and then doing diff a diff, like calculating the difference between the virtual DOM and the real DOM. And where there's a difference, where something is added or removed or modified, then React is going to calculate all of the functions that are necessary to be called in order to update the real DOM to look like the virtual DOM. So the virtual DOM is going to stay in sync with the real DOM, but we don't have to do it. We don't actually have to touch or work with the actual physical DOM. We work with these React elements. So most of your code in React is going to look like line 13 here, where you're going to create and you're going to have functions and so on that return elements. You're not going to worry about putting them into the DOM. You're not going to worry about creating them. You're going to let React handle all of that. Okay, so some other things about working with these elements. I can put attributes on them. So I could say ID equals, intro. This is my intro paragraph. So that is perfectly legitimate. That will work. But I can't do something like this. I can't say paragraph class name equals like that. This is going to cause a problem. Or I can't say on click equals and the name of a function like this, F. This won't work. So the reason it won't work is that I am living in JavaScript, not in HTML. So when you make an HTML element like paragraph and you can say on click equals whatever, that is legitimate HTML, but it's not legitimate JSX because in JSX, my attributes have to use camel casing. So I have to say class name or I have to say on click with an uppercase letter for subsequent words as you're going through. So be careful with this when you're getting used to adding in, if I wanted to say tab index equals 3, that won't work. You have to say tab index equals like this when you're going through. Okay, so a lot of what you know about working with HTML is going to apply, but you have to just, in your head, you have to remember a couple of interesting things. Let's take another one. So let's say I have const URL is equal to https cats.com/image.jpg. So let's say I have this imaginary, URL to a cat. This is my data. And what I'd like to do is I'd like to create an image. So what I'm going to do is I'm going to say the image is equal to, and I'm going to create an image element in JSX like this. So if you think about what an image needs a source. So I'm going to say source is equal to, and what I'd like to do is I'd like to get that value to go in here. So what we talked about before, anytime you want to add any of these attributes that are coming dynamically that need to be evaluated, I'm going to wrap it, instead of using quotes, I'm going to use these braces, and then I can say I want to put the URL right here. Now, another thing that's different about the way that we work with JSX versus HTML is if I was doing this in HTML, if I was writing this, I would say image source equals whatever, and then I would close my tag like this. There is no closing tag for an image element. So an image element is an empty element in HTML. It doesn't have any content that needs to be closed. So here, what would we do? Well, I have to tell React that this is closed. So what you're going to see is you're going to see people doing this. They're going to use what used to be done in XHTML or what happens in XML. And that is they're going to say this is a self-closing tag or a tag that is empty. It doesn't have, a slash image at the end. Like there's never going to be any content here. So when we don't have content, we have something that needs to be automatically closed like this. We're going to put a slash at the end of it. So when you're writing these out, if I was going to say, I want the width to be equal to 250 pixels, that is legitimate. So you can use quotes where you would normally use quotes in HTML to do this. It's also totally legitimate to do this. So height equals 250, right? So these two ways of writing it are equivalent in the sense that in this case, I'm going to evaluate this JavaScript expression. What does it mean to evaluate the number, the numeric literal 250? It's going to evaluate to the number 250. So it's the same as if I said to you, what is 250 plus 1? Well, it's going to evaluate to 251. But if I just have a number like this, it's going to work. So you'll see people doing both of these things when they're working in JSX. And you'll also see them putting in things like this where they, substitute in a variable rather than some literal, or they substitute in a function call or whatever it is. Okay, so another thing to know about these things, I talked to you about this before, but after you create a React element, this image element here is immutable. So React elements aren't going to have their values changed or their children's values changed after they create them. You create them, and what React does is it makes it very cheap to create or recreate these things. So whenever anything changes, like for example, if this URL ever were to change, then what's going to happen is React is going to create a brand new instance of this. It's going to render and create a brand new React element and put that React element into the virtual DOM. So it's very, very cheap and quick to create React elements because they don't go into the real DOM, they go into the virtual DOM, or this DOM that React is managing. And it will take care of figuring out how the real DOM needs to be changed to mirror the new state of what's going on here. This is going to become easier when we look at how to do this with components, so I'm not going to spend more time trying to discuss that right now. So let's talk about this idea of components. So far what we have is we have something that looks like this. We have a couple of lines of code. We have some typical JavaScript code where we have something like this, and we also have code that creates a React element. So if I were to put these two things together, if I were to encapsulate them together, it's possible for me to create a component. So let's look at a couple of ways of doing this. And let's start off with something really simple. So I'm going to write a function, and my function, I'll call it hello. And what hello is going to do is it's going to return a React element. So I'm going to return here, let's return like a paragraph, and I'm going to say hello like that. So this is a really simple React component. It's a function that you can call. And when I say you can call, I don't mean you and me, I mean React. But the idea being that this function can be executed and it's going to produce a React element. So the return type of this thing is a React element that's going to get created from this JSX. At the moment, this isn't very useful. It's not that useful because it doesn't allow us to pass any data to it. So React introduces this concept called props. The idea of props or properties is that I want to be able to pass data down to this component, or if you're thinking about calling a function, I want to be able to pass arguments to a function which change the outcome of how the function works. So if you think of a function as a machine for taking data and turning that data into React elements, that's really what we're talking about with React. We have a machine for producing, it's the thing that sits in between these two. I have a function, component, and it is going to produce those React elements for me. So instead of calling this data, what I'm going to do is I'm going to call this thing, I'm going to call this in the language of React, I'm going to call it props. So props are data that flow into a component by means of receiving them as an argument to a function, like we're looking at here. Props are, as I say, are objects. So let's say, for example, that this hello, I'm expecting to receive a name prop. I'm expecting to receive a property called name. So I might pull the name off of props. I might say const name equals props.name, like so. Now down here, I can return hello name like that. So now I have a more interesting component because it's possible for me to change how it works at runtime. I have the ability to alter what happens. So how do you call this function? Well, it's interesting. This thing is written as a function, but I don't want you to think of it as a function. We're going to call this thing a component. So what is a component? A component is this encapsulation of behavior that takes data from its parent and it returns React elements that represent, given that data, this is how it should look. So what's interesting about this is if I call this function with the same name, so if I pass in Dave, if Dave is the name that I pass in, this component will always return the same React element. It'll return hello Dave, hello Dave, hello Dave, hello. It'll always be the same. So really what I'm doing is I am modeling what happens when my data looks a certain way. If my data looks like this, then my interface needs to look like this. The component is very, very small, and it works with the data to produce this, this output. So the way that you would call this is you would write JSX. So if, instead of saying, like, we would think of doing this, we would pass in an object where the name is Dave, like that. That's how I would think about calling this thing. But in JSX, the way that we do this is the following. So we would say, hello. So this right here is how you call a component or how you use a component. That's probably a better way of thinking about this. I want to use this component. How do I pass in this name? What I'm going to do is I'm going to define that name is equal to Dave, like that. And because I don't have any data that's being rendered inside my hello component, I'm going to just close my component like that. So here we are calling our function. That's the way we're used to thinking about this. And here I am using the hello component. So essentially what's happened is, I want you to notice that when we use intrinsic built-in aspects of HTML, paragraphs, headings, divs, we always use lowercase p, lowercase image, lowercase anchor, all of those kinds of things. When I create my own components, I always begin with an uppercase. So this uppercase hello right here, uppercase hello is significant. It tells React that I am working with a user-defined component. Okay. Now components can use a React component can use another component. So I could have another component, and this other component could, let's just call it person for lack of a better name. And here I could say I'm going to return a div. And because I want to do this on multiple lines, I'm going to wrap this in parentheses like so. So I'm going to going to return a div, and inside this div, I'm going to say that I have my hello component, and the hello component is going to say name equals, and now we need to figure out what we're going to put here. So an interesting thing that's happened here is that the person component is using the hello component. We are making use of it. Hello component is a component that receives props, and on the props, it expects to receive a name. It uses the name in order to say hello inside of a paragraph element. The person component receives props. We currently aren't using the props. And what it's going to do is it's going to render a div, and the div is going to contain a hello component, like so, hello name equals. So what I need to be able to do, maybe I'm going to use my person component like this. Person name is equal to Dave, like that. So what does it mean if I set props on person? I have name coming in here. So it means that here I could say const name equals props dot name, or using this one of the way object destructuring, if we were to say it like this, we could say props const name is equal to props. We're going to pull name off of props, or the way that it'll often get written, we'll just replace props altogether. We'll say that props is an object that contains name. So now I could use name like that, and I will pass name down through to the hello component over here. So the hello component receives props, and I want you to notice how the data is flowing through this application. So I have a very simple set of React components. I have a person component, which is the parent component in this scenario. This parent component is going to render its props, and it's going to have its props look a particular way like this. It's going to have a div and hello, and it's going to pass the name down to a child component. So this way that data flows through a set of React components is really key. This one-way data flow in a hierarchy, so that if the data changes at the top level, so up here where my person is being created, I have a way to pass that data down through my system. So remember we said that if I pass in Dave to the hello component on props, it'll always render hello Dave. And so if that value doesn't change, then the component doesn't need to change in the DOM. So React can be very efficient with this. It knows if the props ever change. So if anything changes up at the top level, like if I have let name equals Dave, and I pass in name as a variable here, what's going to happen is that if this value in my program ever gets updated, it's going to trigger a cascading update all the way down through the component hierarchy, updating every piece of this as it goes. So React is very efficient at managing the state of the entire application based on the flowing of this data from the top down to the lowest part of the components in the tree to figure out what it needs to look like when it actually gets rendered, and then making the adjustments to the actual DOM in order for the application to be rendered correctly inside of the browser. So I want to just say one word about the different styles of how components are built, and then I'm gonna stop talking about theory. This is my third video of theory, and I'm gonna write a program. In the fourth video, I want to write a complete React application for what we did in the first week, and talk to you about lots and lots of different things that we've already looked at, and also extend it with some new ideas. But before we do this, I just want to talk to you about the different ways that components get created. So what we've written here, this is a functional component. Okay? And I want to show you the other ways that this gets written. So it used to be that all components in React were written as classes. And I've talked a little bit about this in a previous video, but let me show you what it would look like. So the way that you would write this in the older way, so this is as a class component. The first thing you would do is you would need to import React, or typically you would import React. Depending on the version of React that you're using, you either need to have React imported or not, but in this case we do, because I want to be able to get the component type out of React. So what I'm going to do is I'm going to say import component from React. So I want to pull in component, and then I'm going to use component to create a class. I'll call it person, and it's going to extend, it extends the component class like so. Whoops. So the first thing that your class component needs is a constructor. And the constructor is going to receive props. And what we need to do is we need to pass those props to the component class constructor. So we have to call our base class constructor. So we do this in ES6 with super props, like that. And then if this, well, I won't get into managing state at all. I'm just going to do this. I'll say that I have a constructor. The constructor receives props, and I pass those props onto the onto the type that I'm extending. I'm going to create a render function, and the render function is going to do exactly what we did below. It's going to return a set, it's going to return a React element or a tree of React elements. And the only change that I'm going to make is I'm going to have to say this dot props dot name, like that. Or another way to write it would be const name equals this dot props dot name, or we could just do the same destructuring if we wanted to. We could say, we could do that. So the differences here, like these two pieces of code are functionally equivalent. Like this is essentially what it's done is it's combined the constructor and the render function, the render method, into a single piece. It's just collapsed them all down into one thing. And the way that the props get managed, there's just less boilerplate. Like I don't have to extend a base type. I don't have to write a constructor. I don't have to worry about where the props, like the scoping of the props. Everything is just a little more immediate. I'm living in the context of a function. So I have a much flatter approach to doing this. And if you are comfortable working with functions in JavaScript, this is going to feel extremely comfortable because scoping isn't an issue. I don't have to worry about this. I don't have to, there's just a lot of problems that go away. There are some things that we will inherit later on where you have to really understand how functions work, and we're going to introduce some ideas later of hooks and being able to persist things in between calls to functions. So I'll talk about that later. But I wanted you to at least see this, to see the difference between the two. So I'm going to prefer, and most of the React documentation now and almost all the code you'll see examples on the web is going to use this functional style. But I wanted you to understand why there's these two approaches. And it's because this is the way we used to do it, and this is typically the way we do it now. Both ways still work. Okay, so I'm going to pause this conversation and I'm going to switch gears. So in the next video, I'm going to take the API, the front-end API that we were working, we had an API that was sending us user profile data. We used it to generate cards, and I did that all using just vanilla JavaScript in the DOM. I want to rewrite it from scratch, and I want to do it all in React. And in doing that, I'm going to show you a whole bunch of the things that we've been talking about, but I'll build it up in a more realistic way rather than doing the theoretical stuff. So I'll see you in the next video for some React programming and building up a little app.